Hi! Today in class we learned about the product rule, so I'm going to go over what we did in class. Kind of a condensed version actually of what we did in class. So when you came in, first it was the bell work, which you did by yourself. Simplify x plus x plus x. Well, I have three x's, and when I'm adding them together, that just becomes 3x. There's not really much to show on that one. But our next one, simplify 3x plus 2 minus 4x plus 1. There's a lot more in that, and so we can show a little bit of work. First I'm going to look at the x's. I have this 3x, and then over here I have a 4x, but I always have to pay attention to the sign in front. So it's actually a minus 4x. So just with the x's, I can do 3x minus 4x. That's like 3 minus 4. Well, if I have 3 on a number line and I have to take away 4, that's going to put me into the negatives. It's actually going to put me to negative 1. So negative 1x. And now I've got plain old numbers. I have a positive 2 and a positive 1. So if I put together a positive 2 and a positive 1, it just gives me a positive 3. So we could leave it like this, negative 1x plus 3. The 1 is a little redundant. You don't have to have it, because if I just write negative x, it shows there's only 1x there, plus 3. Or even I could switch them and make it 3 minus x, because the 3 is still positive and the x is still negative. So I'm allowed to do that. And then question 3, I'm going to write it up here just so I have more space, but it was to solve the equation 0.5x minus 4 equals negative 19. I like to start by drawing a wall. It just helps me remember that whatever I draw or do on one side of the equal sign, I have to also do on the other side of the equal sign. My goal is to get x all by itself. So first I need to get rid of the number that is not directly connected to the x. So directly connected to the x is this 0.5. So that one is stuck to it for the moment. So I'm going to get rid of the 4 because it's a little bit further away. We have to do the opposite operation. So the opposite of a minus 4 is a plus 4. And because I did plus 4 on one side of the equal sign, I have to do plus 4 on the other side of the equal sign. So negative 4 or minus 4 plus 4, that becomes a 0. I like to just cross it off. Some people like to write 0 here. Cool, that's totally fine if you like to do that. Then this side, 0.5x, I'm just going to rewrite it down here, 0.5x, because I didn't do anything with it, equals negative 19 plus 4, so I'm on my number line in the negatives, and then I'm kind of going towards the positive 4 spaces. So you could either do that in your head or use a calculator. It gives you negative 15. If I'm going too fast, feel free to pause the video at any time. Okay, now I have 0.5 squished together with the x, which means it's being multiplied. To get rid of it, I do the opposite operation. The opposite of multiply is divide. So divide by 0.5, divide by 0.5. Now 0.5 divided by 0.5 is 1. Some people like to write the 1. Great. I don't like to write the 1. I just write an x. And then negative 15 divided by 0.5. It's a little counterintuitive, but it actually gives you a bigger number because you're taking negative 15 and splitting it up in chunks that are only half a size, so you can have a lot more chunks. So it actually equals negative 30, which you could use your calculator for as well. So that was our bell work. Then I had you guys open up to page 6 in your notebook and write down the goal. I can simplify exponents using the product rule. And we're going to actually just go ahead and look at that right now, because the next thing is to work with your team on pages 6 and 7 in your notebook. So, product rule, first we write down the goal. Let's see, I think I've got a pen going. I don't know, let's find out. I can simplify, again, we're on page 6, exponents using the product rule. That's the goal for today. And you probably don't know what the product rule is yet because I haven't taught it to you yet, so that's totally fine. Then working with your team, this very first question was a challenge because a lot of people didn't know what it was, and that's totally fine. X to the 5th power is different than 5x. So earlier in the bell work, we did x plus x plus x, and that equaled 3x. So 5x equals x plus x plus x plus x plus x, but notice how that is different than x to the power of 5. X to the power of 5 means not x plus, but x times x times x times x times x. That's x to the power of 5. And x squared means x times x, right? So different than 5x. I just kind of crossed that off so we can remember they're different. So now we're kind of putting those two things together. What does x to the 5th times x to the 2, x squared, mean? Well, we know x to the 5th is this over and over again 5 times, 3, 4, 5, and then I can put a multiplication sign, and then x squared is just x times x. So 1, 2, 3, 4, 5, 6, 7. What's a faster way to simplify that than writing it all out and counting? That's how I know we got 7. Well, we can just add 5 plus 2, x to the power of 7. Much quicker than writing it all out and counting. And that right there is the product rule. Product means multiply. The word product means multiply. So when you have two numbers, I guess you could say, that have the same base. So the base is this bigger font number that's on the bottom. So in this case, x is the example I've used at the beginning. Because x is the same, that's like saying apples times some more apples, and let's count how many apples we have. Then you're allowed to just take this exponent and add it to this exponent without having to write the whole thing out. So some examples: x to the 5th times x to the 6th. Writing that all out, x, 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 right? That would be, take up some space. But the quick version, the quick way to do it, because both of the bases are the same, is you're allowed to just add 5 plus 6 is 11. Now, I'm going to kind of go in a circle, and we're going to save this one for last because it's a little more difficult. So our next one, this one looks challenging, but it's not, don't even worry. So our base, remember I said that's the big font number, the thing on the bottom. Our base is parentheses -2 close parentheses. Okay, so before we had x, now we have this weird looking thing, but that doesn't change the rule. It's still just that thing, and we have 8 of them. And then we have that thing again, so because, hey, same base, we can add them together. But now it says nothing. It doesn't say anything up here. Some people might think, oh, that means there's a 0. Well, 0 means we have -2 0 times. I clearly have it at least once. And because it doesn't say 2 up here, or 3 or 4 or 5, then I know I only have it once. It would only be a 0 if it wasn't even there at all, right? Or if it said 0 already. But if it's empty, then there's an invisible 1. So we can just add 8 plus 1, that's 9. My base stays the same every single time. So now let's go over to this one. No, let's go down first. We'll go down. Here, x squared times y to the 5th, they're not the same base. Can't do anything with them, like we're done. That's the answer. Right? That's like saying apples and oranges instead of apples and apples. If I want to know how many apples there are, I'm not going to go count the oranges also. So it doesn't change because the bases are not the same. Now we sweep up this way. The base is the same. It's a 3 because 3 has the exponent. And then I can just do my trick. 4 plus 9, that's 13, and I'm done. And now let's move to the last one. This is why this one's tricky. Because look, here's a plain old number. Just like down here, 3 was a plain old number with an exponent on it. But 4 does not have an exponent on it. So 4, and then same with 5, does not have an exponent. Those are just kind of numbers. So over here, I've just kind of pushed them off to the side. Like, I kind of ignored them and said, let's just, deal with them later. And so that's what we're going to do. For now, let's just ignore them, deal with them later. Well, now we've got our normal y to the power of 3 times y squared. We just do 3 plus 2, right? The base is the same. I'm not actually allowed to ignore those numbers. So I'm going to do what it tells me to. It tells me to multiply. So I'm just going to multiply 4 times 5. So 4 times 5 is 20. 3 plus 2 is 5. And that's how we got this complicated answer. Again, pause the video anytime you need to, because I'm just cruising through these. So that was page 6. Now we turned in class to page 7 with your team and did some practice that didn't already have the answers. It says write the expanded version I have you write the expanded version because it just helps you practice, it helps you remember, and it helps you recognize like, oh my goodness, I'm so grateful for the product rule. I don't have to do this every single time. Yeah? So x to the 4, 1, 2, 3, 4, and then it tells us to multiply. And then x squared, 1, 2. We already know, like we could have done 4 plus 2 is 6. So there should be 6. 1, 2, 3, 4, 5, 6. X to the 6th. Okay? Y to the 3rd. 1, 2, 3. Times y to the 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And of course, way faster would have been to just add them together, which is y to the 11 plus 3 is 14. Okay, 3 is the base. It has the exponent. So 3 times, and I'm going to do this, I'm going to write the number 3. It's going to be there 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. Multiplication sign, because that's what it tells us to do. Times 1, 2, because there's 2 of them. Again, could have just added them together to get 3 to the 8 plus 2 is 10. Okay, over here, a little challenging one. This 4 does not have an exponent. This 2 does not have an exponent. So we just kind of push those off to the side. I'm going to write multiply because that's what it tells us to do. Okay, push them off to the side. Let's deal with the other stuff. X to the 5th. 1, 2, 3, 4, 5 times, this just says x, so I just have to add an x in there. Now we can simplify all of that. Here it just says x and then blank, sorry, 2 and then blank and then x. Whenever a number and a letter are squished together, it means multiply. So I can go write that multiplication symbol right there. 4 times 2 is 8. I multiply those because they did not have an exponent. Okay, going back to this last one, I didn't do 3 times 3 is 9. Because those do have an exponent, so I do leave it alone and only deal with the exponents. This did not have an exponent, so I do not leave it alone. 4 and 2, I multiply them together. And then x, 5 plus 1 is 6. 1, 2, 3, 4, 5, 6. Okay, this one's fun. 1 to the power of 2 times 1 to the power of 6. 1, 2, 3, 4, 5, 6, 1, 2. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, we can go put all those multiplication symbols in there too. Which equals 1 to the power of 8, but like, come on, what is 1 times 1? It's 1 times 1 times 1 times 1. It's just like 1, so that one is kind of fun. This one, the bases are not the same. That's a y, that's a 7, right? Apples and oranges, I'm not counting the same thing, so I'm not even gonna like do anything else, okay? So, yeah, let's go through and we can finish doing all these. X to the 3, I'm just gonna go ahead and start giving you some answers because this video is already really long. So 3 plus 1 plus 6, 3 plus 1 is 4 plus 6, that's x to the 10. 2 does not have an exponent, so it just stays put, chills. Now y to the 3rd and y to the 5th, they're both y's. So I can add 3 plus 5 is y to the 8. And then z, well, it has nothing else, like it's a loner, so it's just chilling by itself. So sometimes it ends up like this, where we can simplify like some of it, but not all of it. Okay, 5 has an exponent, so we do something with it, right? We do not do anything with it, whatever it is. 5 has an exponent, so we leave the 5 alone, and we just do 2 plus 6 is 8, 5 to the power of 8. 4 does not have an exponent, so we do not leave it alone. 4. 2 does not have an exponent, so we do not leave it alone. 7 does not have an exponent, so we do not leave it alone. But now we deal with all those y's. Y to the 3, y to the 5, and a y to the 1. So 3 plus 5 is 8, plus 1 is 9. And then we would multiply all that together. I cannot do that in my head. Actually, I can. Ooh, let's do it in our head. 4 times 2 is 8. 8 times 7, 5, 6, 7, 8. 7 eighths is 56. So 56 y to the 9. There we go. All right, negative 3 does not have an exponent. Negative 2 does not have an exponent. 5 does not have an exponent. So same as last time, we do not ignore them, we do something with them. But here's a plain old x, there's 1 plus 4 more x's plus 2 more x's, 1 plus 4 is 5, 6, 7, x to the 7. And then we do multiply. Negative 3 times negative 2. Negative times a negative is a positive. 3 times 2 is 6 times 5. 6 times 5 is 30. X to the power of 7. All right, the last one. 17 times 3. Ah, dang it, I don't think I can do that in my head. I don't know. And then y to the power of 3 and z. Well, you can't do anything with that. Y to the power of 3, plain old z. So the only thing we actually got to simplify is 17 times 3. I'm going to get out my calculator this time. Oh, maybe not. I don't know where my calculator is. Okay, well, whatever that equals, that's the answer. So 17 times 3, it's probably like 60 something, 61 maybe. No, that's way too big. 7 times 3 is 21, 51 maybe. 51 y to the power of 3 and z. Maybe you should check that on your calculator before you write that down. So there you go. That was the lesson part of class. And then at the end of class, we did our exit ticket. And this would have been on paper. And now you know the shortcut, 3 plus 12, right? So x, I don't know if I can write on this still. We'll just talk about it. 12 plus 3 is 15, x to the power of 15. Explain in complete sentences, what is the power root of exponents? When the base is the same, and you're multiplying, the base is the same, you have two expressions, base is the same, and you're multiplying, then you can just add the exponents together. That could have been one sentence, maybe you wrote it in two. Extend your thinking, this is so fun. Find the missing exponent b. Well, now we've got y to the power of something, times y to the power of 3 equals 8. Well, that's just like what plus 3 equals 8. What plus 3 equals 8? 5 plus 3 equals 8, so b equals 5. Okay, that was a really long video, but there you go. That's what we learned about in class today. Have a great day.